Hey everyone, welcome to this explainer. Today, we're diving into a massive, fundamental collision happening right now between the way manufacturing has always been governed and the way artificial intelligence is demanding we govern it today. We are unpacking a truly fascinating white paper by industry expert John Katche called PPAP in the AI Era. Now, if you work anywhere near supply chain quality, you already know PPAP, the production part approval process. It is the absolute gold standard for part qualification. But Katche makes a really bold argument here. Traditional PPAP is fundamentally incompatible with modern AI. Why? Because it was designed for a paper world, and AI, well, it just can't govern a paper world.
Today, we're going to cover the paper world problem, the 3 structural PPAP failures, and the IPE framework solution. After that, we'll hit the 6 steps to AI governance, the AI-triggered re-PPAP protocol, and wrap it all up with how to build a living knowledge asset. Let's get right into it.
I want to kick things off with a scenario. Picture this. You've got an AI agent monitoring your production line, and it detects a sustained shift in a critical process input. It's 2:47 a.m. on a Sunday. Can that AI determine just from your PPAP documentation what the approved process window actually is? Can it figure out the required operator action? Does it know when to trigger a resubmission? Under traditional PPAP, the answer is a flat, unmistakable no.
Part 1. The paper world problem.
So to understand why the traditional system crashes and burns here, we really have to look at its original architecture, which is exactly its fatal flaw today. It's treated as a one-time compliance event, not a living process. Think about the number 18. In traditional PPAP, a supplier assembles 18 elements of evidence. You know the drill: design records, process flow diagrams, control plans, capability studies, the whole shebang. You assemble these 18 static elements. You sign a warrant, and you're done. But here is the problem. That knowledge is now trapped in dead PDFs and isolated spreadsheets. It's totally inaccessible to an AI system. Literally, the moment your live manufacturing process drifts, that PDF document silently diverges from reality. It's out of date almost instantly.
Which brings us to Part 2, 3 structural PPAP failures.
When we really deconstruct this, the white paper nails down 3 structural failures that are actively blocking AI integration. First up, data without process context. Imagine your AI encounters a CPK of 0.89 on a critical characteristic. In a traditional setup, it's essentially flying blind. It has zero visibility into which inputs cause that deficiency, because the causal logic wasn't captured in a machine-readable way. Second, we've got static control plans versus dynamic reality. AI is generating real-time signals constantly, but AI-AG control plans, they are written once at launch and almost never updated. And third, the broken linkage. Risk analysis is supposed to flow from DFMEA to PFMEA to the control plan, right? But usually, that link only exists in the memory of the engineers who wrote it. When they leave the company, that chain breaks permanently. An AI just cannot traverse a logic chain that only exists inside someone's head.
All right, Part 3, the IPE framework solution.
So, how do we actually fix these structural gaps? The source material points straight to something called IPE, Integrated Process Excellence. It's a 6-step process deployment framework that literally transforms PPAP into an AI-readable, continuously governed knowledge asset. What makes IP so brilliant is how it solves the upstream gap. A lot of times, APQP is just seen as a chore to generate documents for a PPAP submission. But IPE requires building this knowledge at the very point of design. By the time you actually get to PPAP, the documentation is already structured and the AI governance logic is already baked right in.
This right here highlights the core philosophy of this whole transition. We are shifting from administrative documentation to operational documentation. The paper cites Roger Slater's foundational 1996 principle on operational discipline here. Think about it. Administrative documents just answer what happened. They prove you complied in the past. But operational documents, which is the standard for the IPE framework, answer what should happen and what do I do when it doesn't. They provide executable guidance. AI can't do anything with the historical record. It absolutely needs executable guidance.
And this is crucial because it solves a massive data gap in our supply chains. As you know, AI-AG has 5 PPAP submission levels. Well, level 1 requires nothing but a signed warrant, no supporting documentation whatsoever. So how is an AI agent supposed to govern supplier performance if all it gets is a signature on a piece of paper? It can't. The IPE framework fixes this by setting a mandatory documentation floor. No matter what level the customer formally asks for, the IPE pack captures the full process hierarchy and control logic in a format the AI can read. The submission level just dictates what the customer physically sees, but the IPE pack ensures the manufacturing system actually knows what's going on behind the scenes.
Let's move to Part 4, 6 Steps to AI Governance.
Let's break down how this practically plays out on the shop floor. It's a direct one-to-one translation of human steps into AI architecture. Step 1, creating a positive environment. For humans, that's cross-functional accountability. For AI, it means clearly defined process owners, so it knows exactly who to escalate alerts to. Step 2, defines the process by mapping out an element hierarchy, basically creating an address system so the AI can locate specific elements. Step 3, ditches those disconnected PDFs for an IP pack that the AI can query directly for protocols. Step 4, communicates the process, meaning the AI can actually verify an operator has been trained before production even starts. Step 5, maps real-time SPC to inputs, catching drift before a bad part is ever produced. And finally, Step 6, feeds continuous improvement data straight back into the PFMEA. The AI spots patterns and automatically revises those risk rankings.
Part 5, the AI-triggered re-PPAP protocol.
This brings us to what I think is a major breakthrough in the paper, overcoming the limits of human observation. Traditional standards rely entirely on human eyeballs. A person has to notice a change and say, hey, we need a re-qualification. But AI operates on a completely different level of sensitivity. It spots tiny, gradual shifts in inputs, like material viscosity or injection pressure, way before a human engineer would ever think to trigger a change order. The reality is, the process has changed, but the traditional PPAP hasn't. That is a massive governance blind spot.
To fix this, IPE establishes this really smart three-tier framework. Let's say a variable, like injection pressure, is slowly drifting. In Tier 1, the AI sees it trending toward the limit. It logs it, bumps up the monitoring, but no re-PPAP just yet. In Tier 2, it actually exceeds the approved window. Boom! The AI executes the documented response, flags it, and alerts engineering. But then in Tier 3, the AI detects a sustained shift. The process has settled at a new normal outside the original window. The AI steps in and autonomously initiates a re-PPAP trigger, demanding requalification before things can keep running. We just don't have this structured decision framework in traditional standards, but it's absolutely crucial for the AI era.
And lastly, Part 6, a living knowledge asset.
So, what does manufacturing actually look like when this system is running at scale? Imagine an OEM trying to manage hundreds of suppliers. Manual PPAP reviews? That is a soul-crushing bottleneck. But when you structure PPAPs as IP packs, AI agents can perform these instant, highly consistent first-pass reviews. The AI can instantly verify that high RPN failure modes actually have control plans attached. It confirms sample sizes. It checks if the monitoring frequencies match up with the reported CPK values. It flags a gauge R&R the second it exceeds that 10% tolerance limit. And it instantly spots unlinked PFMA characteristics. None of this needs human judgment on the first pass. It just needs structured data.
Which brings us to the ultimate core takeaway from John Kashat's white paper. PPAP absolutely must be rebuilt. It needs to be a structured process deployment event, not just a document submission exercise. We have to evolve it from this dusty historical record showing what happened into a living, continuously queryable asset that tells the AI exactly what should happen right now.
I want to leave you with a final thought to really gut-check your own supply chain readiness. If your AI agent needs the approved process window right this very second, is your PPAP a living asset ready to provide it, or is it just a dead PDF sitting quietly in a filing cabinet? It's a provocative question for sure, and it's one every manufacturer needs to answer as we plunge deeper into the AI era. Thanks so much for joining me for this explainer, and let's keep questioning how we build the future.